Okay, I have the second float standing up right here up against some steel, and stacked up on top of two pieces of steel is the ruler. So I'm going to do the same thing from this side. I'm just going to look right over everything and just make a scratch mark. Alright, I'm going to keep going with this. There's no need to film the rest of it. Okay, I'm going to cut the teeth on the edge float, so the handle now is on my left, and so it's positioned correctly, so when I drop the file in these cuts, the tooth will be facing the proper way and the float will cut on the push stroke. So there's no need to move the file. The whole area is clear. I have 10 inches of teeth cut through here, and we'll get it going. Let me put my hearing protection on so that I don't hurt my hearing. What would be the best way to do this? Looks good. So that's about a third of the float already done. So I have the teeth cut in this float, and now what I'm going to do is put in my hearing protection and color the teeth in with the magic marker and file them all down so that they're in line. this float was much easier to cut because there's less material to file. Even though it's the same length, it's about a third of the material. So I have some teeth that have to be dropped down quite a bit. So what I'm going to go ahead and do now, before I get going, let me just illustrate one thing before I forget. What I had in some situations was a tooth that was extra far apart from the tooth in front of it and the tooth behind it. So the way to correct that is, instead of going down straight with the file, is to take the vertical face of the file and put pressure against that face and move the vertical face of the next tooth back. So instead of going straight down and keeping that vertical face in position, you're pushing it backwards and re-spacing the teeth. So there's a lot of randomness built into this, but yet there is a strategy so that if the teeth are too far apart, you can set the file down, and instead of pushing down, force the face of the tooth back and correct the spacing of the teeth. The reason you want to force the tooth back is because if you continue going straight down, you'll remove the material, and then you won't have the opportunity to correct it. It's pretty self-explanatory once you get into it. And the good thing about all this is, even if you just left that as a mistake in the float, it's not going to affect the way it performs very much. But you'll see that when these come out real nice, when they look good, they also work real good. So let's get going on this. This is another helpful thing that you might want to try when you're making a float like this by hand, especially when you start off where you just have the marks and you've already made the cuts with the hacksaw. Count the number of strokes that you're making with the file. So in my instance, I think I was around 30, and 30 gets me to the point where I could start tuning them. So rather than go 10 or 15 and then check, and then 20 or 25 and check, you could just count off 30, move, count off 30, move, and so on and so forth. And then you'll have more or less the same depth, and then you can go further. So counting the strokes on the file, you may find helpful. Okay. These are all looking pretty good. Let me take a check here. All right. I think I can finish this up with the fine file now. Spacing looks pretty good. Not bad. Looks good. Chances are it's going to cut good. I'll run a test on it later. So now what I'm going to do, which I already did on the first float, was I put some scuffs in it with the file and roughed up the faces. I'm going to do that to the second file, and I'm going to put the scales on. So I filed the section of the float where the handle is going to go, and I cleaned everything with alcohol. So there's you want to remove all the oils from your hand, the magic marker, anything, and the remnants of the dust from the file, anything that would interfere with the bond from the epoxy. So now I'll mix up some 5-minute epoxy. I usually wait a while for it to set. And I'm not going to pin these because it'll be wood to wood, rather than with the other ones where it was wood to steel, and because it was a 1-inch piece of steel. This is a bit smaller, so I should be able to get away without pinning it. This fits very tightly around the steel, so you really don't want to load this up because it's just going to interfere with the fit, and you're going to have to work with the clamps to squeeze it out. So you're relying on the surface area and the quality of the contact rather than just the amount of glue. So it should work fine. It looks fine. That'll sand up real good. Alright, that looks good. That'll set up real good. So the handles came out real nice on both floats. You haven't seen me test the edge float yet, so let me go ahead and do that. I think it should cut fine. There you go. So very easily cuts a channel. That's what you wanted to do. You could hear it and you could see it and feel it. Cuts very smoothly. So the spacing on the teeth are very nice. Spacing on these teeth just about the same. So it's all done by hand. It's not fancy. It's a simple procedure. I demonstrated every little bit of it. Now what I want to show everyone is how you would use a float like this. The reason why they're so long and the way they're configured that way. So you have here the coffin plane with the large bed. This is extra long because it comes up and comes into the tote. So this would be an example of the way you would hold it. You would have the blank in the vise. Obviously before you shaped it, this would be just all square. And then you could reach in here, like for instance to do the bed, you'd have the flat float, and you could come in here and shape this float. I'm going to turn it over so I don't scratch the plane. But you could reach on both sides, so I can grab it back here and I can grab it on the handle, and I can do all this work with the plane and the cutting area at where it's level, parallel to the surface of the work area, and comfortable in terms of my work height that I like to work. And then I can just go through and do all this work. The most important part is I can hold it on the back and use both hands. Otherwise, if this was a shorter float and I couldn't grab it back here, I'd have to apply all the pressure from this way. Same thing with this. This way I can go in and use the edge float for the wedge pockets and reach all the way through and establish a straight line that goes from all the points that I want up here on the top of the plane to all the points I want to line up at the bottom of the plane, and make this channel where the blade goes to be parallel to the center line of the plane. You've seen me do that before. The other thing you can use this face float for is the face of the abutments where the wedge hits it. I've shown you many times where I recommend that everybody makes that fitting really tight so that it holds the blade in place. So far I haven't had any issues with slipping on blades, and that's a key part of it. And then of course you could always use the back of your floats as a straight edge. So for instance, if I was to make a cut on the abutment, then I can turn the float over and use the back of the float as a straight edge to test the cuts that I made previously. And the same thing with this float. So you're just going to check and you're going to make sure that there's no rocking in here as you're using it. So I'm hoping that these, right now it's just all theoretical, but when I start making planes and I start using them, this is going to pay off. But in any case, you've seen me make these floats, and I think that if you're thinking about making planes, you need to make your own floats. I showed you how. There's going to be more floats coming. The rest of them are going to be configured as skewed floats, and I got about 5 or 6 of them that I have to make. But I'll go through those and you'll watch me make them, and by the time this series is over, everybody will be well versed in float making. Have a good day everybody, and stay strong.